Well, welcome everybody. We appreciate you joining us for our presentation today, and we're going to talk to you about Mainframe Automations. And here at HostBridge, we've spent a good part of the last year working with our customers who are deploying RPA in their enterprise. And what we've learned is that their automations and bots often reach out and touch mainframe applications. And we're going to talk today about a way that you can do that more effectively, more reliably, you get better performance than what the default methods tend to be. We're going to focus today on automation anywhere. We have developed resources and guides for 3 of the main RPA platforms, including UiPath and Blue Prism. So if you'd like to know more about those, please let us know. But thanks for joining us. I want to point out to you that as we go through our presentation today, we certainly welcome questions. If you look at your panel, you'll see at the bottom, there's a place where you can either enter a chat message or a Q&A. Your choice, it doesn't matter. I'll monitor those. During our session today, we will take all the questions we have time for. So with that, let me introduce our speaker. We'll go to the next slide. Many of you probably know Russ Tugner, our CEO and co-founder. Russ pioneered everything we're doing with HostBridge over 20 years ago, including our patent around how to interact with CICS applications using JavaScript. And Russ will be the presenter. He also happens to be the author of the guide on which this presentation is based. So Russ, I know people are anxious to hear from you and not me. I'll let you say hi, but then I want to say one more thing before I turn it over to you.
Well, good morning, everyone. Thank you very much for taking a piece of your day to hang out with us and talk about automation anywhere and RPA in general and how we can allow those tools to integrate as efficiently and effectively as possible with mainframe applications.
And just so everyone knows, we are recording this session, so if you want to share it with someone or watch it again, we will communicate the link to you probably tomorrow, but perhaps if I'm efficient enough, later today. So a couple of things I just want to add. One is robotic process automation is really, by all accounts, taking the industry by storm. It's enjoying rapid adoption. It's making a big difference in the enterprise in terms of efficiency. And we are definitely advocates of RPA. And what we've learned through working with our customers who have deployed it is that often the mainframe automations they create, when they scale up, can have some issues. Russ is going to go into that. And fortunately, there's a really easy way to make sure those mainframe automations are functioning most efficiently and reliably. We have documented everything we're going to talk about today in our guide. You can see the cover of the guide on the screen. There's also a URL. If you want to get any of our RPA mainframe integration guides, simply go to hostbridge.com/mainframe-RPA-resources. You'll find all the things we have to offer there. So I want to just make clear, this is a HostBridge guide. Yes, we are an Automation Anywhere Technology Alliance partner, but we produce this guide, not them. So I just want to make sure that everyone's clear on that, and we're happy to answer any questions you have. So with that, I'm going to let Russ take it from here.
Okay, sounds good. Thank you very much, Jerry. What I thought I would do is just first of all get back on camera just to add a little personal touch and say hello. I'm broadcasting from my home office, as most of us are probably working from our home office around the world. But we've been doing a webcast and interacting with customers via Zoom so much, you're seeing me sitting in front of my green screen as well. So I just wanted to say hello, put a face with a name, and we'll go back on to sharing the screen. And then as questions come up, I may actually switch back over to a whiteboard that I have that we can draw diagrams or illustrate things as required. Let me say just a little bit by introduction of HostBridge. I'll be honest, we kind of go back and forth over the last 20 years how to identify ourselves. Since APIs are all the rage, and rightly so, In the modern world, we kind of describe ourselves frequently as the CICS API company. But even that doesn't necessarily get down to the target of what we help our customers do. And that is quite specifically help them build or implement APIs, and even more specifically, fulfill those APIs. You know, it's one thing to come up with an API that you think is going to be, kind of grand and glorious, and but then how do you actually fulfill the business requirements of the API using your various transactions and programs and data sources running around inside of CICS? That's what we do. We help you implement those APIs, modern APIs, using your existing software and data artifacts. We're probably most known for the fact that we are able to build or implement or fulfill APIs using terminal-oriented CICS transactions without one iota of screen scraping. In other words, without any reference to a row or a column on a screen. And that's because our code lives on the mainframe under CICS, and we're able to interact with those transactions unchanged, but we're able to interact with those transactions such that we never have to worry about the location of fields on a particular screen. We are able to interact with the application on the basis of field name value pairs. That whole discussion is for another webcast, so I'll kind of keep it at that. You can see some of the other distinctive things about our approach, not only with our HostBridge primary product line dealing with integration, but this last bullet, integration analytics, is something that we've been very active in the past year to 2 years. And I'll show you some of what we're doing there. That's also a whole different webcast to help to allow organizations to understand what's really going on under the covers when you integrate with mainframe-based applications. But let's get started here then. So, what are these mainframe RPA-based automations doing? Well, if you look at either Automation Anywhere, which we're focused on today, UiPath, Blue Prism, or any of the other major leading RPA platforms, the way they integrate with the mainframe out of the box by default is using terminal emulation and screen scraping. Now, it's actually understandable why they took this approach, and that is because 9 times out of 10, when you design an RPA bot, you're actually trying to design it around what a human being is currently doing today. And that human being, if they're interacting with the mainframe, are quite typically interacting directly with those applications. As a result, the bots are designed to interact with those applications. That part makes sense, and at least it's understandable. What's not making sense is the fact that when you take an RPA bot, a program really, and now you're automating interactions, high volume interactions with the mainframe using terminal emulation and screen scraping, the performance implications are really bad. And in fact, part of our journey in this space started with a phone call from a customer, and they basically said this: "Hey Russ, I think we got something going on here that we can't see and don't understand. Our business is growing just fine, and our business volume, let's say orders placed, revenue generated, whatever their business metric is, it's growing quite nicely, 10, 15, whatever, some nice percentage per year." He said, "However, our CICS transaction volume is skyrocketing. It's growing exponentially, asymmetrically with the growth of our business. Why?" Well, we began to build some tooling to help them understand that. And lo and behold, it did turn out that a significant bulk of their transaction volume was not being driven by human end users, but was being driven by various forms of RPA, programmatic assets, programs, servers, RPA platforms, Excel spreadsheets that were driving the mainframe transaction volume, and in some cases in rather nonsensical ways. We'll circle back around to that. What I thought I would do, though, is show you a few of the slides that are outlined in more detail in the white paper that Jerry alluded to. So I do encourage you to download that. You can read the full text that accompanies what we're doing here. But first of all, just a word about what you're seeing here. This is Automation Anywhere. I captured these screenshots off my desktop about 3 months ago as I began my own personal COVID lockdown. And what we decided to do with both Automation Anywhere, UiPath, and Blue Prism, as well as our product, HostBridge product called HBJS, we decided to solve the exact same problem a number of different ways, using each of the RPA platforms, interacting with the mainframe using terminal emulation and screen scraping, and then using it to interact with the mainframe using an HTTP RESTful service. Now, so this is the first screen, my control room with my Trader bot sitting there. If you're an Automation Anywhere customer, you know this screen. This is ground zero. By the way, I'll just say, I've used lots of the RPA platforms out there. I quite like Automation Anywhere. I mean, it really, it's simple to use, it's easy to use. The user interface is kind of really simple to kind of learn and use. So it's no doubt in my mind why many organizations have gravitated to it. We are going to create a bot, and I'll just show you this kind of in the slides. We're not going to do it right now in real time. It would take a bit too long. But I created a Trader bot, and you can see that, you know, the Automation Anywhere flowchart here, where I broke it up into a number of steps. So I broke it up into, you know, this step right here, a prologue, then a loop. We're going to loop, do something 4 times, and I'll show you what that is. Then there's kind of an epilogue phase, and I'll show you what that is. Now, what I thought I would do is I'm going to stop sharing on that screen, and I'm going to show you the exact application that we're going to be referencing. So let me come over here, and sorry for the slice of the screen here, but I just want you to see what we're going to be doing from Automation Anywhere. So this is the terminal emulation, a terminal emulator. I happen to be, this is the logon screen for my mainframe. I'm going to go to CICS. And so what I'm going to walk through here is what the bot will do. We'll connect to my mainframe. We'll go to CICS. We will enter our credentials. I'll just press PF3 for now. And we're going to run a transaction called Trader. Now, this is an IBM sample application that has been around for a long time. And what it does is kind of act as a simulated application for stock prices. And so what our bot is going to do is log on to Trader, and then for each of those 4 companies, it's going to select the company, go to the real-time quote screen, grab data off the screen, such as the stock price now, the commission cost, the number of shares held, and the value of shares held. Then we're going to press PF3 again and again. We're going to go to the second company. We're going to do it all over again, grab those, and go back again. Ultimately, we'll go to stock 4. We'll go down there and grab that data, and then we'll do PF3, PF3. We'll get out of the application, and we will log off the screen. So that is what we're going to be doing in the bot. And I know this kind of goes by quickly, but that's going to be the process. So let me go ahead and go back over here. Bear with me 1 second, and every time I switch screens, we have a little bit of housekeeping we need to do. Okay, now, Jerry, I need to reshare this screen here. There we go. Okay. Now, so we're back now on the slides looking at this flow chart with a prologue and a loop 4 times. Now, one of the things that you kind of have to get used to with Automation Anywhere is that when you're using their terminal emulator, they have certain actions that you can do, and only these actions. So from their terminal emulator control, I can clear the screen, I can connect and disconnect, I can send keys, I can do all the typical stuff. The first thing I would notice is there is no session recorder. So we're going to have to do a number of things by hand as we fill out and as we build this bot. Now we're going to go into looking at the prologue step right here. So I'm kind of laser pointing at that. And you can see what we're doing. We are connecting to the endpoint, to the mainframe. We're waiting for HostBridge to be displayed on the screen. We're sending text, CICS. We're waiting again, and then we're sending various bits of data, and we're specifically naming the rows and columns that data has to be, or where that data needs to be typed on the screen. And then we're continuing down ultimately to where we run the trader transaction. Now, let me just, I can't decide whether this is a plus or a minus, but the fact is, when you're using Automation Anywhere to form these sorts of bots, you need to explicitly state, or at least you should, it is highly recommended that you explicitly state the wait conditions after each time you send data. It's a bit of a pain, but the fact is, by specifying clear wait criteria, your bot will run incrementally faster, which is always a good thing. So once we've entered all of these steps and we've kind of modeled them using or described them, then we can move on to actually doing other things. This screen shows you a bit of a detailed view of what the connection process looks like. Again, it's clear that we're going into the mainframe as a 3270 terminal. So we will be using Automation Anywhere's integrated terminal emulator. Again, a little more of a detailed view here, where you can see this is what it looks like from the Automation Anywhere standpoint, where you're typing something. In this case, I'm typing the screen or the string of CICS. I am sending the enter key, and then by default, Automation Anywhere automatically waits a certain number of milliseconds after you send that key. You can, in fact, on this operation, specify waiting criteria. However, I urge you to be careful with that because when you get your input specification and your waiting criteria tangled up, you tend to experience some of the gnarliest problems associated with screen scraping. You know, what we're showing here is there are various wait options. The one that we, actually the only one that we can get to work with 3270 applications is the terminal event called wait till screen contains text. There are a few others, but they don't seem to be quite as reliable as this one for dealing with mainframes. But ultimately, once we get logged on, then we have a prologue step where we can actually begin to interact with a screen. And do note that once we get to a screen we care about, we then have to scrape data. And we name the data that we want to obtain by virtue of its row and column. So in this case, we are getting the content of a field at row 7, column 23, and we are putting it in an Automation Anywhere table. Now, to us, as mainframe folks, this is where the problems begin. Because as soon as we now have created a bot that has these embedded row column references to data on the screen, we now have a point of failure. And that is that if for whatever reason this application changes, even by virtue of one column, if some well-intentioned change now moves the field we want from column 23 to column 25, this bot will break. And that's the problem with building scalable, high value, high volume integrations on the back of screen scraping. Again, what we're doing now is, let's assume we've gone through that entire process. We have in fact scraped all of our screens. And now we're down to the epilogue component here, where we're going to say, okay, we're going to send a PF3. Again, we're going to wait for some screen content. We're going to do another clear, another wait. Then we're ultimately going to log off and confirm the disconnection. So in summary, that's what the bot did or does. When I run that bot, it takes about 24 seconds. Now, as far as RPA bots go, that's pretty good. And the reason it only took 24 seconds to run through those transactions is simply because we, Automation Anywhere really kind of forced us to specify those very specific wait criteria. In other words, wait for this string to show up in that row and column. Although that speeds the bot up, obviously, as we discussed, it also makes the bot more fragile because it's yet one more dependency between the bot's logic and the application screens. But let's just take this kind of as a placeholder in our discussion. This bot took 24 seconds to run. We might be able to optimize it just a little bit more, squeeze out another second or two if we really wanted to kind of make the bot more aware of that application's characteristics. But again, 24 seconds for a bot like this is not bad. Other major emulation or RPA platforms would probably, there's one, in fact, that when we do the exact same thing with it, it takes about a minute. And that's only because it has such generous default waiting assumptions, where it will wait up to 1 second for every interaction with the mainframe. So diagrammatically, this is what we've just seen, and that is that using a platform like Automation Anywhere here in the middle, users can make requests either synchronously or asynchronously, attended or unattended, as we say. And then the RPA platform is going to drive transactions at the mainframe. And literally, we do say hundreds or thousands. In fact, using some of our analytics tools at various customers, the biggest RPA bot we've spotted to date ran slightly over 30,000 transactions against CICS. And stands basically as the worst case scenario we've seen thus far since we've been analyzing this with customers. The bottom line is pretty clear, however, and that is when you're using terminal emulation and screen scraping to achieve integration, the efficiency is low, the latency is high, And the overall cost is very high as well. And we'll look at that in a minute, how all of that, by comparison, comes to be. Now, let me pivot right now and talk about a different way of doing things. What if there was a way that instead of the bot orchestrating and driving hundreds or tens of thousands of discrete requests to and from the mainframe, what if there was a way that it could send one? In other words, what if it could send one request to the mainframe, and then all the automation or whatever is required on the inside of the mainframe, what if all that could be done at memory to memory speeds, and then a single response goes back to the RPA platform? The efficiency would be way high, the latency would be way low, and the cost, we would think, would also be lower. Or we would predict that. Turns out it is true. Well, our way of achieving exactly that is through a tool that we call HostBridge. And rather than looking at this screenshot, I'm going to go over here to this diagram. And the idea is very simple. Instead of orchestrating all the work over in the bot and using terminal emulation and screen scraping, instead, we're going to have the bot send a single HTTP request over to HostBridge, and it's going to call a RESTful service. That service is then going to interact or can interact with any CICS and many non-CICS application and data artifacts, whether they are screen-based, business logic, DB2, vSAM, or lots of others, like CA Ideal, various other types of non-IBM application architectures or platforms. We really don't care. Our goal is to essentially fulfill the meaning and the purpose of that API invocation using your existing CICS-based assets. And then we're going to return a single request back to the bot. Now, this screenshot, I'll go back one slide, is essentially illustrating the fact that our methodology for doing this is JavaScript, modern full tilt JavaScript, running server-side JavaScript, running on the mainframe under the covers of CICS. This is an area we pioneered almost 16 years ago, and many, many large organizations worldwide are using this approach to achieve robust, cost-effective integration to their older, what we might call their heritage application and data artifacts. It's also extremely efficient because HostBridge runs on a specialty engine on the mainframe called a zip. And what that means in practical terms is you won't pay for any IBM software charges associated with any of the integration work that we do running on the zip. So that script, actually in that center pane of the window, that little chunk right there, that little function does exactly the same work as this entire flow there. So that bit of JavaScript did all that flow. And so now let's run it. At least we'll run it via a screenshot here. So now, let's first of all look at how would Automation Anywhere run that? Well, Automation Anywhere, like most RPA platforms, always have a RESTful web service invocation method. So all we did, if you look over here on the left, here's our entire flow in Automation Anywhere. We have a start, and then we send a web services request, and then I took the output, the JSON output, and then I just logged it to a file, and then we're done. I mean, it is that simple from the RPA platform's standpoint. And so then in the middle pane, we you can kind of see it diagrammatic or just line by line. But then on the right pane, you can see what we're doing. I'm sending a request to demo.hostbridge.com/hbscript live demo. I want data for companies 1, 2, 3, and 4. In other words, all of them. And I want to return the data as JSON. And then I'm going to sign the output using an operation that Automation Anywhere supports called, converting RESTful output or a JSON document to a dictionary of strings. Well, when I run that, lo and behold, it runs a lot faster. From Automation Anywhere's standpoint, it ran in 1 second. It might have run less. It's hard to tell because they only measure time down to seconds. On the mainframe, when we look at that on the mainframe, we know that bit of JavaScript, all of those transactions ran in approximately 300 milliseconds. So what we have is a comparison here. In one case, when we use Automation Anywhere to do the orchestration using terminal emulation and screen scraping, it will take roughly 28 seconds to accomplish that. If we invoke the same functionality on the mainframe via HBJS, it will take 1 second from Automation Anywhere standpoint, and from the mainframe's standpoint, takes about 300 milliseconds, at least on our small mainframe. On a much larger mainframe, it would take commensurately less. It's also, again, important to note that this comparison is with the exact same application, the exact same functionality. We didn't change the trader application on the mainframe 1 iota. And by doing it this way, we have had a significantly lower impact on the mainframe. Instead of the mainframe having to worry with fielding thousands of individual discrete input and output response request cycles from terminals, there was simply one RESTful service call that went to the mainframe. We did the processing inside the mainframe at its native speeds, running on a zip, and then returned that response back. Efficiency is way higher, latency drops through the floor, and the cost profile goes down as well. So the way we would summarize the comparison is that from a performance standpoint, there's really no contest. Anytime you use an RPA platform and using techniques like emulation and screen scraping to do high value, high volume integrations to the mainframe, it's going to be slower and cost more. From a resilience standpoint, anytime you use terminal emulation to integrate with an application, it's going to be brittle. And that's just simply because you are creating a binding relationship between an RPA bot running who knows where outside the mainframe and the format of a screen from an application running on the mainframe. And if anything changes there, not just even in the screen content, but sometimes even with respect to the timing in the way those screens are exchanged back and forth, the bot will break. When you're using a RESTful service, the way that we propose, it's extremely resilient because the way that we are interacting with that exact same application does not require any reference to a row or a column. Because we run under CICS right next to it, kind of in memory, then we're able to reference the same data values by virtue of their field name, not their location on a screen. Implementation with using terminal emulation and screen scraping is usually a bit complex. Using RESTful services, it tends to be very, very simple. Depending upon your volume, we judge the mainframe impact of emulation and screen scraping to be moderate to high. Again, depending upon your volume, we would judge RESTful services hitting those same transactions to be low to moderate. That kind of leads.
Russ, before you finish out, and let me just let everyone know we're very close to the end of our presentation. We've already got the great question, and if you have other questions, please go ahead and submit those, and we will get to those here in just a few minutes. So thank you for that.
Thanks, Jerry. So this leads us to our recommendations for your existing automations. If you have automations in place today where you are using bots, Automation Anywhere or any other, and you are using their terminal emulation and screen scraping capability to interact with mainframe transactions, we encourage you to let us help you and do a Mainframe RPA analysis. I'll show you what that is in the next slide. But we can essentially take a small set of SMF data for an interval of time and actually help you visualize and see what the impact of RPA is or may be on your mainframe. From that, we can also identify maybe some high priority opportunities for automation using a different way, or for optimization using different techniques. For new automations, if you have new requirements, we would certainly obviously encourage you to take a look at HBJS. Instead of codifying all the screen scraping and emulation activities down in a RPA platform such as Automation Anywhere, it's just as easy, and for some customers far easier, to codify them as a RESTful service on the mainframe. And as a result, they will run substantially faster and without any screen scraping. I mentioned the idea of what we call Mainframe RPA Analysis, and I'll just show you a couple of screenshots here. We have a whole different webcast we do on this topic, but what we're able to do is take a set of SMF data and be able to deduce from it lots of information about the impact of RPA against the mainframe. This particular screen is just an activity analysis, and we, from this analysis, we were able to determine that for this interval of time, which was really just 2 hours during one processing period, we were able to deduce that there were almost 38,000 RPAs that were ran against, this is a CICS region. And as you can see, on a relative basis, the robots are definitely winning, definitely driving more work than the human activity. We also, in this analysis, we provide back to you what we call our DNA analysis, where we're able to look and see what are these bots doing. And if you look down here where my little laser pointer is, right down here, you can kind of get an idea of what we can do and deduce. So for example, here was a bot that ran an RPA sequence. We know the date when it started, when it stopped, and we can deduce this quite easily. Well, not easily, but we have proprietary techniques to deduce this out of the SMF data. It ran for almost 10 minutes, 599 seconds. It ran a total of 6,746 transactions, consuming 14 seconds of CPU time, which is staggering given the model of their mainframe. And what this RPA did was it went to the menu transaction first, and then it transitioned to the catalog transaction, and it screen scraped it essentially interacted with that transaction, screen scraping 6,745 entries. Likewise, the one below, the next one we caught, I think this display was sorted in descending order by RPA total, involved over 4,000 transactions. This was a little different. Someone wrote a bot that would go to the order transaction, gather up some data, then would go to the menu transaction over to a pricing transaction. And we showed this to the subject matter expert, and they were able to deduce from the DNA report very quickly that someone had written a bot to be able to confirm the most advantageous pricing for those orders. Now, our objective in showing the DNA is just that, so that a subject matter expert in your organization can look at that and maybe have an aha moment where they say, oh, I see what they're doing. And in fact, on that first bot, the one that screen scraped the catalog transaction, the subject matter expert looked at that and said, oh, now wait, every night we generate that data and we put that data out on an operational data store as a PDF file. This group of users don't know that that data exists already in a different place that's actually more convenient. So they literally, all they had to do, the remediation for that top bot was call the user, let them know they don't need to do this anymore. The second example was a little different. The subject matter experts looked at that and said, well, that's kind of an interesting thing. We understand why they're doing that. But that should really be kind of a batch process that we do, or an on-demand process, rather than running 4,000 transactions consuming 15 seconds. And so they kind of looked at that and took that bit of DNA, that RPA activity, as a requirement, and are considering using our approach with HBJS, or they may write a batch job, who knows. But nonetheless, we now have a practice and a product within the company where we can do this sort of analysis, and we are very happy to work with prospective customers. If you'd like to see what this analysis yields from your data, just give us a call and we'll talk you through the process of sending us maybe an hour or two of SMF 110 data from an active CICS region, and we'll see what we find. Okay, to summarize, here are our bottom lines. As mainframe RPA activity scales, it can have a negative impact, and that is, and what we mean by that is when you're scaling RPA activity using kind of the default terminal emulation and screen scraping approach, not just can it have a negative impact, it will. We find that in many of organizations that we're interacting with, this impact is expensive, and frankly, it's largely not well understood. It's not seen. And that's because there really haven't been tools like this to have a microscope and see what are the RPA bots doing. Because bear in mind, most of the RPA initiatives that are being stood up in organizations around the world are really outside the purview of the individuals and groups that control the IBM mainframe and its applications. And so a lot of this is just happening. And we're helping organizations with these tools to be able to see and calibrate not only the impact, but the cost. And I suppose that's another thing I'd like to leave you with, and that is that we do have tools, services, and expertise and solutions to measure the impact and certainly optimize the way that RPA platforms like Automation Anywhere interact with the mainframe. Jerry, I'll stop there and certainly just put my own contact information up here. If anyone has any questions, just reach out to us. and we would love to interact about your requirements and how we might be able to work with you to optimize your automation anywhere deployment. Jerry?
Yes, and we do have some questions, so let me tee those up for you. They're the rest of the questions you love because they're of a technical nature, but before I get to those questions, let me just encourage you to ask any others you might have.
Do I need to get my whiteboard ready?
Perhaps you might need it. And you can ask whatever you wish about this. Our expertise, as you hopefully understand by now, is making CICS applications available in the best possible way. So here's the first question that we have. Both of these are from the same individual. So first question and a follow-on. Here's the first question. When you were talking about CPU consumption, what was the relative CPU consumption difference, zip versus GCPU?
Let's see here. So let's go back over here. I think we're still on that screen. Okay, Jerry, are we back?
We're on the discussion and question. Yeah, you're back in the slides.
Okay, good. Let me just get this diagram right here to use it from. When you run, and forgive me, I hope I'm not blinding you going through these. If you run 1,000 transactions over here on the mainframe, let's say it's just 1,000, those 1,000 transactions are going to consume X amount of CPU. Then there's going to be a certain amount of CPU time that's going to be devoted to all the interactions. In other words, all of the inputs and the outputs, sending data into and out of from each one of those transactions. But let me just say, and by comparison, those exact same target transactions will run over here. In fact, let me get this. The exact same transactions are going to run. The difference is twofold. One is, instead of having thousands of inputs and outputs from the distributed side, from outside the mainframe coming in, instead of having thousands of 3270 interactions, which do consume some CPU time, we're going to have a single HTTP request. And then the point regarding zip enablement is that our orchestration that I'm highlighting here, all of this runs on the zip. Now, I can't do anything. In fact, I'm precluded from zip enabling your application transactions. So they will still run on the GP engine as they do today. But all of our orchestration will run on the zip. So that's the JavaScript orchestration. And then we have traded thousands of individual discrete input and output operations to the mainframe and CICS for a single HTTP operation, which when we compare that too lowers the GP CPU burn.
Okay, and we're happy to go into more detail if you want to get with us for a one-on-one conversation about that. We have lots of experience with those measurements. So here's the follow-on question from the same individual, asked also, is this captured via event processing on field name using a JavaScript API in CICS?
Let me go to this diagram. Now, I apologize. I don't know if wait, there we go. There it zoomed in. So yes, so what we're trying to illustrate here in this slide is look over here to the right, and you can see kind of a mock-up of a green screen. That is kind of a rendition just purely for the script author to look at and to be able to know what the field names are. Now look over here at the actual reference to get the field. So in other words, in this JavaScript, when we say get field value, we don't say row 3, column 5, or whatever it is. We actually use the name of the field called held, or share now, for how many shares do you, or what is that, share price now. And then held times share price now, I think in the application, yields the value. So we reference these field names. These are the names that were originally assigned in a BMS map to those field values, perhaps a decade or 20 years ago. And you can rearrange every field on the screen. And as long as the field names don't change, this script will not break. If you add fields to the screen, but held, share now, and value are still there somewhere, then this integration will not break. If you want to reference that new field, then obviously you need to reference it by its name. Now, if you delete a field from a screen, let's say you move the value or you get rid of value from that screen, then that particular statement will throw an exception, and it will tell you that the field name value is no longer on that particular BMS map.
Russ, you have been answering questions without knowing it as they've come in. And we just got another one relative to what you just shared. What if you want to access a non-mapped field?
Excellent question. It does happen. And even in that case, what we will do is we have another get field function that will let you access the screen space in a number of different ways. Meeting customer requirements for the last 20 years, we built all sorts of objects and operators to do this. If it is a non-BMS field, full disclosure, yes, we may in fact be forced to denote the location of data on a screen by its geometry. However, we've actually created a number of techniques to be able to sequester that knowledge and automatically generate that knowledge. Our view is that again, everything that we do to implement this runs on the mainframe. Our view philosophically, or I guess my view, is that you absolutely never want to expose row column coordinates on screens outside the mainframe, because A, things will break. Your change control systems likely don't span all the way from your CICS apps out to your RPA bots. And everyone forgets about the interconnections. And as soon as things break, a state that we call application rigor mortis sets in. Everyone is afraid to change anything. However, even in those rare cases where you do have to reference rows and columns, you want to do that on the mainframe, closest to the application. Again, because you only want those sorts of you don't want those implementation details to leak outside your mainframe, and certainly never across a formal API boundary.
Okay, yes, those are great questions that you all asked. If you have any more, please enter them now. We have just a few minutes left, and while we see if anyone else has a question, let me say to you, we have a number of resources that can help you. As Russ shared, if you would like to just get some insight into what's happening with respect to the way RPA has been deployed in your enterprise, we have the tools, the expertise, and the analysis capabilities with a little bit of input from you in the form of SMF records to show you some things that might not be obvious about how all that's performing. The other thing that we have available is if you want to prototype developing some of these RESTful services for certainly your automations or any of your integrations, we have a program that lets you do that at no risk and at no cost. So you can get our software. We'll provide support to you to get it installed, and we'll even help you develop your first set of integration scripts and test the results. And we have found almost without fail that when people do that, they really come to value this particular approach, the way it performs, and how fast and easy it is to implement. So we have all that expertise. We can help, and we'd be happy to do that. So one last call to see if anyone else has a question or a comment. And Russ, if you want to go to the last slide, just put up your information again, if you would. Certainly feel free to reach out to us afterwards. We will send an email out to everyone who registered with a link to the recording if you want to watch this again or share it. But seeing no more questions, let me just say thanks for your time and attention. We would love to help you with your mainframe automations or any of your CICS integration requirements. Thanks, everybody. Have a great day.